Hello everyone. Today we are going to solve some problems based on properties of Laplace transformation. So these properties will help us to solve more complicated problems in a simple way. Usually properties will make problems very simpler. We have three important properties of Laplace transformation in our syllabus. So before going to properties of Laplace transformation, let us remember few standard functions of Laplace transformations. Laplace of 1, it is 1 by s. Laplace of e power at, it is 1 over s minus a. Similarly, e power minus at, it is 1 over s plus a. Laplace of sine at, a divided by s square plus a square. Laplace of cos at, s divided by s square plus a square. Similarly, Laplace of sine hyperbolic at, cos hyperbolic at. Laplace of t power n, it is gamma of n plus 1 by s power n plus 1, where gamma of n plus 1 is n factorial. So Laplace of t power n is, we can also write Laplace of t power n as n factorial by s power n plus 1, etc. Okay, let's go to properties of Laplace transformation. As I said, we have three important properties of Laplace transformation in our syllabus. First one is shifting property. So what is shifting property? If Laplace of f of t equals f bar s, then Laplace of e power at into f of t is nothing but f bar of s minus a. Similarly, if Laplace of f of t equals f bar s, then Laplace of e power minus at into f of t, this becomes f bar of s plus a. Second one, if Laplace of f of t equals f bar s, then Laplace of t power n into f of t. Laplace of t power n into f of t equals minus 1 power n d power n by ds power n into f bar s. So this is nothing but derivative of transform property. This is shifting property. We have one more property, that is integrating property. Laplace of f of t equals f bar s, then Laplace of f of t divided by t. If we have t in the denominator, then the transformation will be integral from s to infinity f bar s into ds. So these are the major properties of Laplace transformation. So first one is shifting property. In this we have Laplace of if Laplace of f of t equals f bar s, then Laplace of e power at into f of t is f bar of s minus a. And second one, if we have minus here, then we'll get plus there. So next, second one is a derivative of transform property. If we multiply t for f of t, then we will differentiate one time. If we multiply twice, I mean t square, if we have t square into f of t, then this becomes minus 1 whole square d square by ds power 2. Will differentiate f bar s twice with respect to s. And the last one is, if we have t in the denominator, or if we multiply 1 by t for f of t, then we integrate the f bar s. Let's solve problems by using these properties one by one. I'm going to solve few problems based on first property, that is shifting property. So what is shifting property? If Laplace of f of t equals f bar s, then Laplace of e power at into f of t is f bar of s minus a. I will take this as f of t. F of t equals 2 into cos 5t minus sin 5t. Then what is the Laplace transformation for this? Laplace of f of t equals 2 into Laplace of cos 5t minus Laplace of sin 5t. So 2 into, what is Laplace of cos 5t? We know Laplace of cos 80, it is s divided by s square plus a square. By using that, we have s divided by s square plus 5 square, it is nothing but 25, minus Laplace of 5t is a divided by s square plus a square, it is s square plus again we have 25. So this is our f of t, but we require e power minus 2t into f of t. So here f of t is 2 into cos phi t minus sin phi t. Now I am going to apply first property. So shifting property, if you have exponential term in the question, then we are going to apply shifting property. So this is our f bar s. So Laplace of e power at into f of t is f bar of s plus a. What is f bar of s plus a? We have 2s divided by s square plus 25 minus 5 divided by s square plus 25. Here replace s by s plus a. So s plus a means here a value is 2. So replace s by s plus 2. We will get 2 into s plus 2 divided by s plus 2 whole square plus 25 minus 5 divided by s plus 2 whole square plus 25. So we can take s plus 2 whole square plus 25 as common or as LCM, s plus 2 whole square plus 25. It is nothing but 2s plus 4 minus 5. It is 2s minus 1. So this is the required result. Similarly, if we have e power minus t into cos square 3t, find the Laplace transformation for this. I will take f of t as cos square 3t. What is the formula of cos square t? It is 1 plus cos 2t divided by 2. Then this becomes 1 plus cos 2t is nothing but 1 plus cos t divided by 2. So Laplace of f of t equals 1 by 2 into Laplace of 1 plus Laplace of cos 60. 1 by 2 into Laplace of 1, it is 1 by s, plus Laplace of cos 60, it is s divided by s square plus 36. Then Laplace of e power minus t into f of t is 1 by 2 into replace s by s plus a. Replace s by s plus a. Here a is 1. We will get 1 by 2 into s plus 1. So 1 by 2 into 1 over s plus 1 plus s plus 1. S plus 1 whole square plus 36. So this is the required result for e power minus t into cos square 3t. Let's solve some more problems on shifting property. Next problem. Find the Laplace transformation of sine hyperbolic at into sine at. So if we have sine at into sine bt, then we can apply the formula of sine a into sine b. But if we have sine hyperbolic at into sine at, then we need to apply the sine hyperbolic at formula. What is the formula of sine hyperbolic at? So sine hyperbolic at is e power at minus e power minus at divided by 2. So apply this formula to here. We will get sine hyperbolic at into sine at equals 1 by 2 into e power at minus e power minus at into sine at. So into sine at. Then multiply this. We will get 1 by 2 into e power at minus e power at into sine at minus e power minus at into sin at. Then what is the Laplace of this? I will take this as f of t. Laplace of f of t is 1 by 2 into Laplace of sin at. Laplace of sin at is a divided by s square plus a square. Replace s by s minus a. Now I am applying shifting property. Minus again Laplace of sin at is a divided by s square plus a square, and replace s by s plus a, because we have e power minus here. So here replace s by s minus a, because here we have e power at. So 1 by 2 into a divided by s minus a whole square plus a square minus a divided by s plus a whole square plus a square. So if I take a outside, a by 2 into, it is nothing but a square plus b square minus 2as minus 2ab plus a square minus 1 over a square plus b square plus 2ab plus a square. So I can write this as a by 2 into a square plus a square minus 2a is nothing but a square plus 2a square minus 2as minus 1 over a square plus 2a square plus 2as. If I take LCM, we will get, it is in the form of a minus b into a plus b. So it is nothing but a square plus 2a square whole square minus b square. It is 4a square s square. Then a square plus 2a square plus 2as, s square plus 2a square minus 2as, s square plus 2a square, s square plus 2a square will get cancelled, will remain with 4as. So this is the required result for sine hyperbolic at into sine at. Next problem. Find the Laplace transformation for the function 1 plus 3t into e power 2t whole square. It is in the form of a plus b whole square. So I will take this as f of t. F of t equals a plus b whole square, a square plus b square 9t square e power 4t plus 2ab, 2 into 3, it is 6t into e power 2t. Then Laplace of f of t equals Laplace of 1 plus 9 into Laplace of t square into e power 4t, or e power 4t into t square plus 6 into Laplace of e power 2t into t. So what is the Laplace of 1? It is 1 by s. Plus what is the Laplace of t square? T square is, we have already 9, it is 2 factorial by s cube. Now we need to replace s by s minus 4, shifting property, plus 6 into Laplace of t, it is 1 divided by s square. We have e power 2t, so replace s by s minus 2. Then we get 1 by s plus 9 into 2, 18 divided by s minus 4 whole cube plus 6 divided by s minus 2 whole square. This is the required result. Now I am going to solve some problems on second property, that is derivative of transform property. So what is derivative of transform property? If L of f of t equals f bar s, if L of f of t equals f bar s, then Laplace of t power n into f of t equals minus 1 power n d power n by ds power n into f bar s. This is the result for property number 2. Let's solve one problem. Find the Laplace transformation of t into cos at. So t into cos at, I will take this as f of t because problem will be in the because this problem is in the form of t into f of t, t power 1. So I will take f of t now. What is f of t? It is cos at, because we need to find f bar s by applying Laplace. What is Laplace of f of t? It is Laplace of cos at is s divided by s square plus a square. This is our f bar s, because we know Laplace of f of t is f bar s. Now I am going to apply the derivative property. It is Laplace of t into cos at, t into cos at, Laplace of t into f of t. We have 1 in the place of n. Then this becomes minus 1 power 1 d by ds into f bar s. So minus d by ds into, what is f bar s? It is s divided by s square plus a square. Then we need to differentiate by using quotient rule. So apply quotient rule now. Denominator whole square, s square plus a square whole square, denominator into s square plus a square into differentiation of numerator, it is 1, minus numerator s into differentiation of denominator is 2s. So finally we get minus s square plus a square minus 2s square, s square minus 2s square, it is minus s square plus a square divided by a square plus a square power 2. So if I multiply minus here, we will get the result as s square minus a square divided by s square plus a square whole square. So this is the required result for Laplace of t into cos a t. Suppose if we have t square here, then we need to differentiate this again. Let's solve one problem on t square. T square into sin a t. Okay. As usual, I will take f of t as sin a t. F of t as sin a t, then Laplace of f of t. What is Laplace of f of t? Laplace of sin a t. It is a divided by a square plus a square. This is our f bar s because Laplace of f of t is f bar s. Now I am going to apply derivative property. Laplace of t square into f of t. We have n equals 2 now. So it is minus 1 whole square into d square by ds square into f bar s. Minus 1 whole square is plus 1. D square by ds, I can write d square by ds square as d by ds into d by ds of f bar s. It is a divided by a square plus a square. D by ds into differentiation of this with respect to s. It is nothing but s 1 over, it is in the form of 1 by s, minus 1 by s square. It is minus 1 by s square plus a square whole square into differentiation of a square is 2s. We have a here, it is minus 2as. Or we can solve this by using quotient rule also. Next we need to integrate, we need to differentiate this again. It is denominator square, a square plus a square power 4, denominator into a square plus a square whole square into differentiation of numerator is minus 2a minus numerator into, already we have minus 2as, so plus 2as into differentiation of denominator a square plus a square whole square, it is 2 into a square plus a square into 2s. So this is the differentiation for minus 2as divided by a square plus a square whole square. Take common. Now we have 2a into a square plus a square as common. Next we will remain with a square plus a square minus a square plus a square plus, if we take 2a into a square plus a square as common, we will remain with 2s into 2s, it is 4s square divided by a square plus a square power 4. A square plus a square, 1 a square plus a square will get cancelled. We will get 2a into 4 square minus a square, it is 3a square minus a square divided by a square plus a square whole cube. So this is the required results for t square into sin a t. Next, if we have t cube in the question, and then we need to differentiate thrice. For example, let us take t cube into sin hyperbolic t, sin t. T cube into sin t. What is f of t? It is sin t. What is Laplace of f of t? It is 1 over a square plus 1, which is nothing but f bar s. Then Laplace of t cube into sin t is, Laplace of t cube into sin t is minus 1 power 3, replace n by 3, t cube by ds cube into f bar s, it is 1 over s square plus 1. minus 1 whole cube is minus d square by ds square into, I will apply 1 d by ds here. Differentiation of 1 over s square plus 1 is minus 1 over s square plus 1 whole square into 2s. So minus into minus plus d by ds into minus and minus plus, so d by ds into, now I am going to apply one more time. So differentiate this denominator square, it is s square plus 1 power 4, denominator into s square plus 1 whole square into differentiation of numerator, it is 2. I have taken this minus outside, so minus into minus plus, minus numerator 2s into differentiation of denominator is 2 into s square plus 1, 2 into s square plus 1 into 2s, into 2s. Next, d by ds into, I will take 2 into s square plus 1 as common, 2 into s square plus 1. Next we will remain with s square plus 1 minus 2 into s square plus 1. I will take this part as common, 2s into 2s, it is 4s divided by s square plus 1 power 4, s square plus 1 and 1 s square plus 1 cancel, that is d by ds into s square plus 1 whole cube into 2 into s square plus, so 4s, sorry, this is 4s square, s square plus 1 minus 4s square, it is nothing but 1 minus 2 into 4s square minus s square, it is 1 minus 3s square divided by s square plus 1 whole cube. Let's differentiate this one more time. I will take this outside, I will take this 2 outside, differentiate this again. I am applying the derivative third time. So denominator square s square plus 1 power 6, numerator s square plus 1 cube. I have already taken this 2 outside. So differentiation of 1 is 0, differentiation of minus 3s square is minus 6s, minus numerator, it is 1 minus 3s square into differentiation of denominator 3 into s square plus 1 whole square, it is in the form of x cube differentiation 3x square, so 3 into s square plus 1 whole square into 2s. Let's take 6s into s square plus 1 whole square as common, 2 into, I will take 6s into s square plus 1 whole square as common, will remain with minus s square plus 1 minus 3 into 2, 6, 6s s square plus 1 whole square common, will remain with 1 minus 3s square now, overall divided by s square plus 1 power 6, s square plus 1 whole square, and this will get cancelled, will get 4, and the final result will be, if I take 6s outside, it is 12s into, we have minus 1 minus into minus plus 3s square, so 3s square minus s square, it is 2s square, minus 1 plus 3s square, so 3s square minus s square, we have minus 1 and also we have minus 1 into minus 1 is minus 2 divided by s square plus 1 power 4. If we take 2 as common, we will get 12 into 2, 24 s into s square minus 1 divided by s square plus 1 power 4. So this is the required result for t cube into sin t. If we have t cube into sine hyperbolic t, then we don't need to differentiate this twice, because we can take sine hyperbolic t as Laplace of sine hyperbolic t as a divided by a square plus a square also, and also we have one more method. If we apply formula for that sine hyperbolic a t, that is e power a t minus e power minus a t divided by 2, then we can simply solve that. Let's apply that. See, we have sine hyperbolic t, we can write this as f of t by sine, f of t as sine hyperbolic t, and Laplace of f of t as sine hyperbolic a t, that is nothing but 1 divided by s square minus 1 as f bar s, then we can differentiate this thrice to get t cube into sine hyperbolic t by applying derivative of transform property. But if we apply shifting property, we can solve this very easily. So t cube into, what is sine hyperbolic t? It is e power t minus e power minus t divided by 2. That f of t equals 1 by 2 into, if you multiply this, t cube into e power t minus t cube into e power minus t. So Laplace of f of t equals 1 by 2 into Laplace of t cube is 3 factorial by s power 4. For e power t, I will replace s by s minus 1. Similarly, this one minus 3 factorial by s power 4, and I will replace s by s plus 1. So 1 by 2 into 3 factorial is 6 divided by s minus 1 power 4 minus 3 factorial again 6 divided by s plus 1 power 4 also. So we can take 6s outside, we will get 3 in the numerator, and we can simply solve this. So this is our required results for t cube sine hyperbolic at. So we don't need to apply derivative transform property when we have hyperbolic along with t cube. Okay, let's solve some problems on property number 3, that is integrating transform property. That is, if we have Laplace of f of t equals f bar s, then Laplace of f of t by t as f of t by t is integral from s to infinity f bar s into ds. For example, 1 minus e power minus at divided by t. So it is in the form of f of t divided by t. If I take f of t as 1 minus e power minus at. Let's solve this. So f of t equals 1 minus e power minus at. What is Laplace of f of t? We have Laplace of 1 minus Laplace of e power minus at. Laplace of 1 is 1 by s minus 1 over Laplace of s minus a is Laplace of e power minus at is 1 over s plus a. This is our f bar s. Now I am going to apply the Laplace property number 3. F of t divided by t. Divided by t means integral from s to infinity into f bar s into ds. What is f bar s? 1 by s minus 1 over s plus a into ds. Next, integrate this with respect to s. So what is the integration of 1 by x? It is log x. So apply that, we will get log s minus log of s plus a. Integration of 1 over s plus a is log of s plus a, limit from s to infinity, and we have the formula log m minus log n. It is log m by n. Log s divided by s plus a, limit from s to infinity. So apply the limit. If I give upper limit here, we will get infinity divided by infinity. So infinity by infinity is indeterminate form. We can't apply infinity directly. So I will not apply this upper limit now. I will keep as it is. Limit s tends to infinity, s divided by s plus a. I will get later. Minus, apply the lower limit. Replace s by s only. So we will get the same thing. Log of s divided by s plus a. For this, we need some simplification. Laplace of limit from s to infinity, s divided by, if I take s outside, we will get 1 plus a by s. 1 plus a by s minus lower limit is s divided by s plus a. Yes, cancel. Now we can apply the limit now. Apply the upper limit. We will get 1 divided by 1 plus a by s. A by infinity, what is infinity? It is 1 by 0. So a divided by 1 by 0, 0 goes to numerator. We will get 1 plus 0. Sorry, I have forget to write log. So log of this, log s divided by s plus a. 1 over 1 plus 0 is 1 only. What is the value of log 1? log 1 is 0 minus log of s divided by s plus a, because log 1 is 0. And finally we have minus here, this goes to log, it is in the form of n log m. So we can write this as log of s plus a by s. So this is the required result for 1 minus e power minus at divided by t. Okay, next problem. Find the Laplace transformation for this cos at minus cos bt divided by t. I'll take solution f of t as cos at minus cos bt. So what is the Laplace of f of t now? Laplace of cos at, s divided by s square plus a square minus Laplace of cos bt, s divided by s square plus b square. This is our f bar s now. Laplace of f of t by t. Apply the third property, integrating transform property. It is limit from s to infinity f bar s into ds. What is f bar s? S divided by s square plus a square minus s divided by s square plus b square into ds. Next we need to integrate this. To integrate this we require 2 here, because we have s square plus a square in the denominator. So differentiation of s square plus a square is 2s. If we have the differentiation of denominator in the numerator, then the integration will be log of the denominator. So for that we have s square plus a square here. So differentiation of s square plus a square is 2s. So we require 2 here. So multiply and divide by 2 now. Multiply and divide by 2 now. Now we'll get 2s divided by s square plus a square. Differentiation of denominator is 2s. We'll get that in the numerator. If the differentiation of denominator is in the numerator, then the integration will be log of the denominator. By using that, I can write this as log of s square plus a square, integration of 2s divided by s square plus a square, minus again this log of s square plus b square, limit from s to infinity. 1 by 2 into log m minus log n, it is log of s square plus a square divided by s square plus b square, limit from s to infinity. So we need to apply the limit. So we can't apply the upper limit infinity. Then I'll keep the upper limit as it is, because if I apply infinity, we'll get infinity plus a, that is infinity by infinity. Infinity by infinity is indeterminate. So keep our upper limit as it is, log of s square plus a square divided by s square plus b square, minus apply the lower limit, we'll get the same thing, log of s square plus a square divided by s square plus b square. So one by 2 into limit s tends to infinity, log of, take s square common now, or take s square outside, 1 plus a square by s square, again s square, take it outside, 1 plus b square by s square, minus log of s square plus a square divided by s square plus b square. So this s square will get cancelled. If we apply the limit now, we can easily write log of 1 plus 0 divided by again 1 plus 0 minus log of s square plus a square by a square plus b square. So what is the value of log 1? It is 0. So 1 by 2 into minus log of s square plus a square, s square plus b square. So log of, if you apply minus to inside, so it is s square plus b square, s square plus a square, and we have 1 by 2 also. By using that 1 by 2 we can write log of square root of this n log m power n, that is 1 by 2. So this is the required result for cos AT minus cos BT divided by T. In some question paper we can find the question as cos 6t minus cos 2t divided by t, like that. If we have cos 5t minus cos 4t, suppose the problem will be like this, cos 5t minus cos 4t divided by t, then the answer will be log of a square plus b square is what? 16. Log of square root of a square plus 16 divided by a square plus 25. Simply change b by 4 and a by 5 if you find like this. Okay, let's solve some more problem. Okay, next problem, find the Laplace transformation for the function sine AT by t. So f of t equals sine AT, then what is the Laplace of f of t? It is a divided by a square plus a square, which is our f bar s. Then what is the Laplace of f of t by t? What is the Laplace of f of t by t? We will get, integration from s to infinity a divided by s square plus a square, this is our f bar s, into ds. A into a is constant, take it outside. What is the integration of 1 over a square plus s square, 1 over a square plus s square? It is 1 by a into tan inverse of s by a, standard result. So I can write the integration of 1 over s square plus a square as 1 by a into tan inverse of s by a, limit from s to infinity. A will get cancelled. So apply the upper limit. Apply the upper limit now. What is the value of tan inverse of infinity? It is pi by 2 minus tan inverse of lower limit, as it is s by a. So minus tan inverse of s by a. So pi by 2 minus tan inverse of s by a. We have the formula tan inverse x plus cot inverse x equals pi by 2. So by using that I can write this as cot inverse of s by a. So this is the result for Laplace of sine AT by t. If we have e power 5t now, then what is the result for this? Apply shifting property now. So apply the shifting property. It is nothing but cot inverse of, replace s by s minus phi, that's it, s minus phi divided by a. So this is the required if we have e power 5t here. Okay, so we have solved some problems on properties of Laplace transformation, that is first property, shifting property. So in the shifting property we have exponential term along with f of t, like e power minus 5t into f of t, like this. So in the second property we have multiplication of t with f of t. In the third property we will get f of t divided by t. Now I am going to solve one problem which includes all the three properties. So for example, like find the Laplace transformation of 2 power t plus cos 2t minus cos t divided by t. For this I will apply property number 3. I will take one more, t into sin t, property number 2, and okay, I will take e power minus 5t also to apply property number 1, that is shifting property. Let us solve this. For time being I will take this as f of t, g of t, h of t, just to make problem simpler. So what is the Laplace of f of t now? What is the Laplace of f of t? So Laplace of f of t is Laplace of 2 power t e power, I can write 2 power t as log 2 into t, because we know e power log x is x, e power log x is s. I can write this as e power log 2 power t, e power log 2 power t. It is in the form of log m power n. What is log m power n? It is n log m. So I can write this as 2 into t. So it is nothing but e power at. What is the Laplace of e power at? It is 1 over s minus a. So I can write this as 1 over s minus log 2. So this is the Laplace transformation for 2 power t. Now I am going to solve the second one, Laplace of g of t. So what is, I will take Laplace of cos 2t minus cos t. What is Laplace of cos 2t minus cos t? It is s divided by s square plus 4 minus s divided by s square plus 1. I will take Laplace of cos 2t minus cos 5t divided by t. Laplace of g of t by t. So this is nothing but our g bar s. Though then the result will be integral from s to infinity f bar g bar s into ds, s divided by s square plus 4 minus s divided by s square plus 1 into ds. So as we know, we require 2 here. So multiply and divide by 2 to get the differentiation of denominator in the numerator. Because if we have denominator differentiation in the numerator, then the integration will be log of the denominator. So I can write this as log of, I will directly write this log of s square plus 4 minus log of s square plus 1. That is 1 by 2 integral from s to infinity. 1 by 2 into log of s square plus 4 divided by s square plus 1 from s to infinity. So this becomes 1 by 2 into limit s tends to infinity. I'll directly take s square as common, because we already know these type of problems. So I'll take s square. It is 1 plus 4 by s square divided by, again s square common, 1 plus 1 by s square minus lower limit, it is log of s square plus 4 divided by s square plus 1. So s square cancel, apply s tends to infinity, we will get 1 by 2 into log 1 minus log of s square plus 4 divided by s square plus 1. So final result will be log of, so log 1 is 0, this minus goes to inside, so it is s square plus 1 divided by s square plus 4, and this is root for 1 by 2, that is log of m power n. Next we required with this Laplace of sin t. I will take this as equation 1, I will take this as equation 2. So what is Laplace of sin t? It is 1 over s square plus 1. What is Laplace of t into sin t? It is minus d by ds into 1 over s square plus 1. What is the differentiation of 1 over s square plus 1 now? It is minus 1 divided by s square plus 1 whole square into 2s. So Laplace of t into sin t is minus into minus plus 2s divided by s square plus 1 whole square. And also, so here I have applied property number 2. So here we have e power minus phi t also. If we take e power minus phi t to here, then apply shifting property, replace s by s plus phi. 2 into s plus phi divided by s plus phi whole square plus 1 whole square. I will take this as equation 3. So finally the Laplace transformation for this, I will take this as star. Laplace transformation for this is, by using equation 1, 2, 3, we can write 1 over s minus log 2 plus log of square root of s square plus 1 divided by s square plus 4 plus 2 into s plus phi divided by s plus phi whole square plus 1 whole square. So This is the required results. In this problem, we have applied all the three properties of Laplace transformation, that is shifting property, derivative transform property and integrating transform property. I think you have understood better now. Okay. Try to solve these problems. So these are all your assignment work problem. Try to solve this e power 8, first one e power 8t into sin 5t into sin 3t. Now first apply sin a into sin b formula to here, then find the Laplace for that. Finally apply e power 8t, that is shifting property, replace s by s minus 2 for the result of f bar s. For the second one, first find the Laplace for sin t, it is 1 over s square plus 1. Then apply integrating transform property, that is integral from s to infinity into f bar s, that is 1 over s square plus 1. After finding sin t by t, finally apply e power minus t, that is replace s by s plus 1. And next one we have sin cube t minus cos cube t, apply sin cube theta formula and cos cube theta formula. Then differentiate that with respect to s once, because we have t power 1 here. Next one we have t into e power 5t and minus 2 into sin 8t divided by 2 also. And also find one more problem, because we have only t here. Try to solve this also, t square into cos 4t. Try to solve these 5 problems. So today we have solved some problems on properties of Laplace transformation. In the next video I will explain the Laplace transformation by using periodic functions.